tangents. Now, a tangent is a straight line that touches a curved graph. Now, we only know two curved graphs, the parabola and the cubic function. So what is important that you should realize is a tangent is a straight line. So we use the straight lines formula to get to the equation of a tangent. Then there are three new terms that you need to know in order to do the homework and future lessons. The first term is abscess. That means x value. The other word is ordinate. That means the y value. And the third one is normal. Normal is the line that's perpendicular on a tangent at a point. So the normal is the perpendicular line on the tangent at a point. Okay, let's look at our first example. I give you a parabola and they say find the equation of the tangent where x is negative 1. So, in other words, if I have the parabola, at a certain point of contact where the parabola and the tangent touches, not cuts, touches, the x value is negative 1. Now, in order to answer these type of questions, you will need three columns. You only need these three things when you have to get the equation.
And if it crosses, you basically maintain it.
Yes. Yes, we'll do an example where it crosses. Okay. Then it's not a tangent anymore. A tangent only touches. Right, the parabola is 2x squared minus 5x minus 3. And we know the tangent touches where x is negative 1 on the parabola. The first thing that we know is the point of contact, and x is negative 1. Now I'm going to show you how to think to get to the equation of the tangent. Because tangent is a straight line. This x value, you can substitute there in that x value. So what I write here in red is what you think and what you do in pencil. So I already have x's value. How can I get the y value of the point of contact? Because this y value I can substitute there. So how do I get the y value?
Substitute the x in the parabola.
Yes. I substitute the x value into the parabola. Right. So y will be equal to 2 times negative 1 squared minus 5 times negative 1 minus 3. And then you'll get y equals 4. Therefore, my point of contact will be negative 1 and 4. And we can write this 4 in pencil at the y. Now I also need m, the gradient, and I need c, the y-intercept of the tangent. I can get m. How do you get a gradient? With the first derivative. not equal to 0, that gives you the turning point on a cubic function. Only the first derivative. First derivative is gradient. Right, so I need the first derivative. The first derivative in this case is f accent x, but I don't have an f, I have a y. So to indicate that you know that you have to differentiate y, we write, I take y and I differentiate x.
What if you start by saying y is equal to fx and say that?
Yeah. Then you can say it is 4x minus 5. And this you call the gradient function. You've just worked out the first derivative, and that is my gradient function. I'm going to use this to work out m. How do you think will we get m? Substitute the x value. Can you see why this x value is so important? I substitute it there and here. So m is equal to 4 times negative 1 minus 5, and then you get m is negative 9. So I can put in my negative 9 in pencil. Can I work out c? Yes, I have all the values. So I'm going to work out c. Therefore, 4 equals minus 9 minus 1 plus c. And you will get that c equals negative 5. Now you can write your equation. Therefore, the equation of the tangent is y equals m is negative 9x minus 5. Very easy. Do you agree? Any questions so far? Can you all hear me with this noise outside? The next example, they tell us that the gradient of the tangent is 2. So the gradient is 2. Therefore, under my gradient column, I'm going to write the m is 2. But what do you know about the gradient? It is the first derivative. So, therefore, because the name of the function is gx, you have to write g accent x equals 2. I don't have an x or a y value. I only have m. So what must I do now? Wow. Yeah, I'm going to use this gradient function. So I have to differentiate that, set it to 2, and then solve x. Then I have my x value. When you have your x value, how can you get the y value? You substitute the x into the g function. Then you have y, and then you have x, y, and m, and you can calculate c. Alright, let's do that. Gx, I'm going to write gx here. Accent x is 2x minus 4. But the first derivative is equal to 2. So 2 equals 2x minus 4. And then you can get x equals 3. Now I want the y. Yeah. Okay, to get y, thank you. Now I want the y value. So I'm going to substitute the x into the original one. 3 squared minus 4 times 3. Oh, yeah. To get the y value, I'm going to substitute the 3 into the x values, and then you'll get y is negative 3. So my point of contact will be 3, negative 3. Those two values I can substitute into my equation. The y is negative 3, x is 3, and my m is 2. Now I can work out c. So y will be equal to mx plus c. Negative 3 equals to 2 times 3 plus c. And you'll get c is negative 9. Therefore, y will be 2x minus 9. Any questions here? Our third example. Now they give you a cubic function. And this is where your question comes in. They say the tangent, let's make it an orange one. The tangent and gx, let's make gx green. It intersects at t, where x is negative 1, and at b. Now these 2 points, t and b, have different names. What is t's name and what is b's name?
T is a tangent.
T is not a tangent. The orange line is a tangent. So T is
Contact.
point of contact. What is B? Intersection. Okay, so point of contact, we do what we do in this lesson. Intersection, how do I get B's coordinate? You make the 2 graphs equal. But before I can get to B, I must first get the tangent's equation in order to set it equal to the cubic function. Alright. So the first question is, Determine the equation of the tangent at x equals -1. So we know that the x at t is -1, and we know the x is -1. This I always do in pencil.
And we get a graph of t from t point of contact.
Yes. Um, where must I start now? At the -1, so we have to get the y value. So g of -1 equals. I'm just going to give you the answer. It's 13. You know how to get that. So we're going to write this is y is 13 and y is 13. How can I get m? First get the first derivative, then substitute x with -1. Mooi. So the first derivative is -9x squared plus 4x minus 3. Then substitute the -1, and then you get -16. So my m is -16. And now you can work out the tangent.
Linear function. Can we also use first derivative to get the
Yeah, that's a quicker way. So, y will be equal to mx plus c. Y has a value of 13. M is -16 times -1 plus c. And you can work out that c is equal to -3. So, my tangent equation is y equals -16x minus 3 at point x equals -1. Now they want you to get the coordinate of b, and we've already decided that's where the tangent is equal to the cubic function. So I have to write the tangent function -16x minus 3 is equal to -3x squared cubed plus 2x squared minus 3x plus 5. And if you get everything to the left, you'll have 3x cubed minus 2x squared minus 13x minus 8 equals 0. Then you follow all those steps like get the factor, do synthetic division, get the second factor, factorize the second factor, and then finally you'll get x equals -1 or x equals -1 or x equals 8/3. Yes.
Ask, should we always try to make the highest power positive? So take the function that
Yes.
I was gonna ask. Okay, it's fine. So you're gonna have to follow that. You can't just go to a calculator. You can only do that for one of them.
Yeah.
And how do you know when we're supposed to do synthetic division? It's really not right.
I assume that you know already.
But does it count box? Like when do we know if it counts?
If I give you a function and I ask you to do synthetic division. So I have my 3 x's. Can you see that 2 of them are the same? What does that mean? It bounces on what? No, not necessarily. It bounces on the tangent. So if you have 2 x values, up until today, it was bouncing on the x-axis, but it can also bounce on something else. In this case, it bounced on the tangent. So we know that t is definitely -1 at the x value. So this will be my b's x value. So the x value of b will be 8/3. We substitute 8/3 either into the tangents equation or the cubic equation, and then you'll get b's y value as -137/3. But this was not what they asked. They asked a coordinate of b. Therefore, you have to answer in coordinate form. Therefore, b will be 8/3 -137/3.
Could they ever ask us to get the graph? I mean, when one graph is
Yes, then you do it like this. Right. Now there's an errata on your notes where they showed you how to calculate the y value from 8/3. There must be a -16 and the b coordinates. Our last example, in this case they give us the tangents equation. And now they ask you, calculate the value of p, so that is c. Do you agree? Okay. And they say this equation is a tangent to this cubic function. So where must I start?
You have the graph between differentiate and then subtract 3. That's the equal.
Yes. This 3 is my m. Therefore, if I say m is the first derivative of x, I can say 3 equals to the first derivative of x. So let's start there. The first derivative is 6x squared minus 3, and that is equal to 3. And then you work out, you'll get x squared equals 1. To get x alone, you need to take the square root on both sides. And if you put a square root in a sum, your answer will always be positive or negative. So x will be equal to a positive or negative 1. That means that this tangent can either touch my cubic function at x is positive 1 or at x is negative 1. That's why I said get the values of p.
What does that mean?
That means that my tangent, because there's a variable in the tangent formula, this tangent can either touch, let's say the equation looks like this, or the graph. So my tangent can either touch the graph here at -1 or here at 1. So it can be a tangent like that or a tangent like this.
So it can be 2 tangents.
It can be either one of them. Okay. Good question. Exam question. Now, I have two x values. So it can be +1 and a y or -1 and a y. How do I get the y? Substitute into fx. Okay, I'm going to do it the short way. F of 1 gives me negative 2. F of negative 1 will give me a 0. Therefore, my 2 points of contact can be either be 1, negative 2, or negative 1 and 0. Are you back with me? I'm sorry about the noise outside. What do I do now? Now you're going to take the first coordinate, substitute it there, and get your first possible tangent equation. And you're going to do the second one, substitute it in there, and get the second possible tangent equation. Let's do that. So the first one can either be y is negative 2 equals 3 times 1 plus p, and then you get p is negative 5, or y is 0 equals 3 times negative 1 plus p, and you get p equals 3. And end your question with what I asked. Determine the values of p. Then you say, therefore, p can be negative 5 or p can be 3. Any questions? This is not difficult. Do you agree? It's very easy if you follow these 3 columns. Start with what they give you and then work towards the sides. Alright. Your homework for this lesson is exercise 12, page 57, more or less, number 1 to 10, and your project for today. I'm going to hand it out now. This homework must be done for Tuesday, and the project must be done for Monday.
So Monday we're gonna have another lesson.
Yeah. So don't leave all this homework for Sunday afternoon. It's too much. Divide it up. If you take 10 and you divide it into 4, you should do 2 to 3 questions a day.